Hello class. In this video, I'm going to show you how to solve absolute value equations with x on both sides of the equality. So in this problem, I have just that. I have an absolute value of 2x plus 5 equals 3x plus 4. So in this case, x is on both sides of the equality. The first thing I'm going to do is isolate the bars. And in this case, the isolation is already done for us. So the second step is to split into positive and negative case. So I'm going to go ahead and do that. Plus, minus. The positive case is exactly the way it looks. So 2x plus 5 equals 3x plus 4. While the negative case is 2x plus 5 equals negative outside of 3x plus 4. All right, so let's go ahead and solve it. The first thing we need to do is subtract 3x from both sides. This will get all our variables on one side, so negative x plus 5 comes down equal to 4. Then I subtract 5 from both sides to get all the numbers on one side, so negative x comes down equal to negative 1. Then I divide by negative 1, and x equals 1. X equals 1 is a possible solution of this second 2x plus 5 comes down equal to negative 3x minus 4 when I distribute the negative. I add 3x to both sides, plus 3x. In this case, 5x plus 5 equals negative 4. So again, I added 3x this time, but I ended up with 5x. Now I subtract 5 from both sides, and 5x comes down equal to negative 9. And x is equal to negative 9 over 5. So these are possible solutions to my set. Why do I say positive or possible? Because I need to check them out. So with these on both sides, you're going to have to check out 1 and negative 9/5. So I'm going to check out 1. The absolute value of 2 times 1 plus 5. Sorry about that. The absolute value of 2 times 1 plus 5 should equal 3 times 1 plus 4. Let's check it out. 7 equals 7. That's a true statement. So 1 is actually one of my solutions. Let's check out negative 9/5. So we need to plug in negative 9/5. Absolute value of 2 times negative 9/5 plus 5 should equal 3 times negative 9/5 plus 4. All right, at first glance that might not work, but let's check it out. I don't really want to work with this in my head, so what I'm going to do, because of the fraction, is just turn on my Desmos. That seems like the easier thing to do. So if I go to Desmos calculator, I'm just going to plug in 2 times negative 9/5 plus 5. So absolute value 2 times negative 9/5 plus 5 will get me, oops, let's put that in bars, I guess. Yeah, that works better. So 1.4 is on one side, and then 3 times negative 9/5 plus 4. So 3 times negative 9/5 plus 4. Give me a negative 1.4. So this turns out to be positive 1.4. Positive 1.4 tries to equal negative 1.4, and that is not correct. That's a false statement. So this is not one of my solutions. So this is what we call an extraneous solution, meaning it is a solution, but it's an extra solution that I don't want because it's not true. So with these problems, you have to check all your answers, unfortunately. Let's go ahead and erase this. Let's do a couple more examples here. So in my next example, I have to split after I isolate. So to isolate, I subtract 7 from both sides, and 5x minus 1, still in the bars, equals 3x minus 7. Unfortunately, the 3x and the 7 can't combine, so I'm stuck with that phrase. So now I have a variable on both sides, but more importantly, I have the bars isolated, so I'm going to split into a positive and negative case. The positive case is going to be 5x minus 1 equals 3x minus 7. And the negative case is going to be 5x minus 1 equals negative 3x minus 7. All right, so I need to solve both those. I subtract 3x from both sides, and 2x minus 1 equals negative 7. Then I add 1 to both sides, so 2x comes down equal to negative 6. Then I divide both sides by 2, and x comes down equal to negative 3. In this, I'm going to have to distribute the negative. So 5x minus 1 equals negative 3x plus 7. Now I add 3x to both sides, so 8x minus 1 equals 7. Add 1 to both sides, 8x equals 8. Divide both sides by 8, x equals 1. So again, these are possible answers. Possible answers. What I need to do is check them. Negative 3 in there is going to be absolute value of 5 times negative 3 minus 1 plus 7 should equal 3 times negative 3. Let's check it out. 5 times negative 3 is negative 15. Minus 1 is negative 16. 16 plus 7 is 23. That does not equal negative 9. So 23 not equal to negative 9 means that it's no solution. Right here, this is not a solution. Let's check the other one out. 1. We have 5 times 1 minus 1 absolute value plus 7 should equal 3 times 1. 5 times 1 minus 1 is 4. plus 7 is 11. And that comes down equal to 3? No, they're not equal. So 1 is not a solution either. So here I don't just have one extraneous solution. Both of my solutions are extraneous, so there is no solution. Both my answers turned out to be bad answers. So that's why it's very important that you check your work. All right, last one. The bars are isolated here, so I go right to my split. Positive and negative. X plus 7 equals 2x plus 8. And here I have x plus 7 equals negative 2x plus 8. Subtract 2x from both sides gives me negative x plus 7 equals 8. Subtract 7 from both sides, negative x equals 1. Divide both sides by negative 1, x equals negative 1. Over here we got x plus 7 equals negative 2x minus 8. And I'm going to add 2x to both sides. 3x plus 7 equals negative 8. Subtract 7 from both sides. 3x equals negative 15. And divide both sides by 3. X equals negative 5. Now, negative 1 and negative 5 are possible solutions. Now I have to check. So I have absolute value of negative 1 plus 7 should equal 2 times negative 1 plus 8. Let's check it out. Negative 1 plus 7 is 6, should equal negative 2 plus 8 is 6. So that checks out. Negative 1 is actually one of my solutions. Let's check out negative 5. Absolute value negative 5 plus 7 should equal 2 times negative 5 plus 8. Negative 5 plus 7 is 2 equals negative 10 plus 8 is negative 2. Well, that's not true. So negative 5 is not a solution to my absolute value equation. So negative 1, I only have one solution here. All right, that concludes part 2